Okay, so we talked about lists. Now we're going to talk about a set. So a set is also another type of container inside of Java. When you had a list, that's usually something you want to iterate through. A set is when you want to just ask, do you have this element? And so it's going to be a little different in its implementation. Also about a set is that everything must be unique. Otherwise it won't add it, just like sometimes a set in mathematics. But in Java, a set has to have unique elements. Objects added to a set must define equals to establish its uniqueness, and a set does not maintain order. So when a list, you had a sequential list of items, like a grocery list. But in a set, you just have a set of items, and they're in whatever order. And the reason for this is by letting them be in whatever order, it allows you to quickly ask, do you contain something? The three main ones are called a hash set, a tree set, and a linked hash set. I'm only going to go into the details of a hash set. The tree set uses something called a binary tree, specifically a red-black tree. When you go into data structures, it'll talk about you'll get your fill of trees, trust me. You'll go plenty of discussion about trees, why they're efficient, why we use trees. But the big difference is a hash set maintains no ordering. A tree set maintains sorted order at all times. I'll talk a little bit about why that's useful. A linked hash set is just a way to it's like a hybrid of a hash set and trying to maintain some ordering. Okay. So there's different implementations of a set. But what is a set? Well, a set, you can ask its size. Is it empty? Does it contain an object? Add an object, remove an object, be able to iterate through it, ask it to contain all. Contains all certain items, and then you can add all and remove all, as well as retain all. All right. What's going on here? Well, basically, what? Did someone say something? Everything. All? Yeah. A lot of all. Well, not quite everything. But the point of a set is if you want to test, maybe if S2 is a subset of S1, you ask S1, do you contain everything in S2? And it would return true if it is a proper subset, just like in set theory in math. Have you all had to do sets in math?
Yes.
Yes, you have? I mean, just asking other people. So hopefully this is somewhat intuitive. Not so much? What?
I don't remember.
You don't remember? You can have S1 be the union of S1 and 2 by doing add all. So I'll add everything to the set. And then you can do intersection with retain all. And now, what was the intersection? Those are the elements that they both have. Union are elements.
It's anything.
Anything in both. It's a combination.
Oh, yeah.
There you go. And you can also set it to the difference. So you can actually remove everything from S2 that's in S1, and then it'll remove it as well. Okay. Let me go ahead and jump over here and let's do a couple of examples with sets. Set examples. Go and add that in. Public, static, void, main, string, args.
What kind of benefits do you get with using a set?
What kind of what?
What's the benefit of using a set?
So by using a set, first off, there's no duplicates, so it's going to automatically prevent extra items from being in your list. You're only going to have one. Also, you're going, as hopefully you'll see soon, trying to ask if something is contained in the set is very, very fast. But trying to iterate through the set is going to be slower. Because a list is meant for iteration. A set is asking, do you contain this?
So you were saying a set, so that you couldn't have like 2 ones in a set? You'd only have
In a Java set, no.
Okay.
Now they do create something called a multi-set, which allows duplicate elements, but we're going to stick with standard Java sets, which do not allow multiple elements.
So how is it faster? It doesn't have to go through? Like, does it just like send out a big, I don't know.
So we're going to talk about hashing right after I do some set examples, and then I'll explain to you why it is so incredibly fast. So I need to make sure everyone's on board about what a set actually does first, because I've learned that's where a lot of the confusion lies. So we're going to go on, let's create a set. We'll just stick with integers. I'll just call it a lowercase set, and we'll make it a hash set. All right. So we can do for int I equals 0. I is less than 1,000. Do 1,000,000. And you know what? I don't want to retype the code, so let's go ahead and make these. Well, no. Let's make it simple. Set.add new integer of I. That way we know 1 through 1,000,000 has been added to this set. And let's go ahead and actually create the correct for loop. Okay. Add 0 to, what was it? 1, 2, 3, 1, 2, 3 to set. I'm actually going to call this S1, so we know it's set 1. Okay. Now if you can do system.out.println S1.contains, and you can do new integer of 1, 2, 3, 1, 2, 3. All right, let's go ahead and run that real quick. Oops. Right, doesn't equal it because we didn't go all the way up. So let's go less than or equal to. Okay, true. Okay, why do we actually care about this? Well, let's go ahead and bring in our list example, because you might be asking, why aren't we using something else like an array list or a linked list? I try to explain that, but I think it's better when you actually see it happening. And we'll go ahead and do all.add and new integer sub I. And so we can do here long start time equals system dot nanotime, and we'll just do boolean found equals s1 dot contains new integer of 1, 2, 3. All right, and then long end time equals system dot nanotime. Then we do long duration equals end time minus the start time. This gets the duration, and then we'll do duration divide equals 1, 2, 3, 1, 2, 3. That converts to milliseconds. So I'm just going to print out it took duration and then milliseconds. All right. So let's go ahead and run that. Now we're using set, so it took almost nothing. That makes sense. And let's go ahead and see if the list takes any longer. It may not, because we may have to increase our values. Oops. Found equals. There we go. Run that out. Took 17 milliseconds. Oh, so there is actually somewhat of a difference. You know what? Let's even increase this by a little more. And then let's run it now. Probably take even longer. Wow. Didn't expect it to be that much longer. There we go. 41 milliseconds? Oh, because it has to add everything to the list first. Yeah, so that it was a lot of time spending on creating it. So I'm going to go ahead and knock this down a little, and then we're going to put this in a quick for loop just to do a lot of contains. There we go. We'll do it 1,000 times. Let's do it 100 times. All right, 630 milliseconds. All right, that's good. And then we'll do boolean found of the set. We'll run the same exact code. Almost nothing. All right, so it couldn't even read how fast it went, is the difference here. Do you see that this is actually an insane difference? Yeah, this is pretty crazy difference. Okay. I'm going to go ahead and wrap this up in a separate function just to showcase public static void show contains difference. I'm going to go ahead and take this code, cut paste. I'm going to call show contains difference. And I'm going to actually make this a little nicer. So for the list, it took that long, so that will be this guy. And then we're going to, down here, copy pasta. Right now we don't need to redeclare our variables, so I'm going to get rid of long. This is just to have one thing that shows both times for you. And then we'll say convert. And then down here we can just quickly say for this set, it took that long. Okay, let me give a couple more comments just to make this a little clear. Find the time for contains on a list, and then down here we'll do find the time for contains on a set. Let me go ahead and run it just to make sure it's a little pretty for you all. Am I calling the wrong one?
Close.
Yeah, it's because I didn't actually call set.
Oh.
I called the list twice. All right, there we go. Okay. Now, well, you might say, well, maybe the linked list will go faster. All right, let's see if the linked list goes any faster. Let's go ahead and put that in there. So linked list, see how long that takes. Oh, it actually is slower. Okay, so we don't want to do that. And there is a tree set, and I suspect the tree set is going to be slower than the hash set. Okay, maybe not. So the tree set is still blazingly fast. Yeah, the performance actually is not that big of a difference due to the underlying implementation. But we're going to just talk about a hash set. Okay, so that's the contains difference. Now, so you understand the performance difference going on here, right? So if you are going to do contains, or I should go back here. Do you want me to do examples of each of these four for y'all, or maybe just pick one, just to show you performance-wise? Contains all, add all, retain all.
Do the retain all.
Do the retain all. Thank you. Setting to the intersection of S1 and S2. Great. All right, let's go do that. So let's do a retain all example. Comment that out. Public static void retain all example. All right, so we'll go ahead and create another set, S1. And we'll go ahead and create another one called S2. I'm in insert mode. There we go. And let's make a for loop, adding 0 to 1,000,000. And then let's do another for loop. This one will do, what am I going to do? That's 5,000, 50,000, 500,000. And we'll add that to S2. And then you can do, so you want to do the intersection, right? Yeah, so S1 dot retain all from S2. So what do you think S1 will be after that? Intersection of S1 and S2.
500,000.
500,000 to 1,000,000.
Oh, so it does all.
Yeah, it's an intersection of all the elements. Maybe to make this a little easier to read, let me take off some of these zeros. We'll go from 100, 0 to 100, and this one will go from 50. Ooh, let's do this, 150. There we go. So if you do a retain all, what should it be? 50 to 100.
So will it print out every single value, or will it just say like 50 to 100?
So right now if I do system.out print line, I can say, whoops, S2 has a size of I go s1.size. I hit do it as a size of 51. That makes sense. And if how would I iterate through this? Show all elements of S1. How would I do that?
You can't use an iterator, right?
Boom.
Oh, you can.
I'm going to show you how you do that in a for loop.
Did you say it's really slow though?
Using an iterator inside of a for loop
Oh.
instead of calling .get. So equals s1.iterator it.has it dot. Oh, I have to import it first. Next. And actually, you don't need anything after that. So then you just see system dot. Let me print it out this way so it makes more sense. Integer, the integer, or I'll call it element. Integer element equals it.next system.out.println of the element. And that'll just print out a bunch of elements. So if I run them, it says the size is going to be 51, and then it prints out from 50 to 100. If I didn't do retain all, what did I do instead? Add all. That might be good. Add all. What do you think it would do instead?
Would add all of S2 to S1.
Right. So then what would be the size afterwards?
150.
151. And then the elements would be 0 to
150.
150. Yeah, let's go run that real quick. Yeah. 0 to 150. Okay. So hopefully all these are somewhat straightforward. Okay, any questions about set? I've showed you what the big performance difference. And next I'm going to talk about hashing, which explains why we have such a huge performance difference.